In this video, we are going to be solving radical equations. So our equations today are going to have square roots, fifth roots, cube roots, fourth roots in them, and we are going to use inverse operations to undo those radicals. So here's our steps for the equations that we're going to solve today. You do probably want a calculator with you because we are going to be taking some roots and also raising some numbers to different exponents. So your first step is to isolate the radical. You want to get the expression or the term with the radical totally by itself first. Then to undo that radical, you are going to raise each side to the power of the index because those are inverse operations. So for example, if you had square root, you would raise each side to the power of 2 because exponent of 2 and a square root are inverse operations. Or if you had a cube root, you would raise each side to the third power, fourth root to the fourth power, fifth root to the fifth power, and so on. Those are inverse operations and they will get rid of our radicals for us. You're probably going to have to keep solving after you've raised each side of the equation to a different power. Once you finish solving, you might get multiple solutions. You might get one solution, two solutions, but we need to check for those extraneous solutions in these problems. Now, we've talked about extraneous solutions before. Those are solutions that, you generate when you're solving these equations, but when you go back to plug them in, they don't really work. So we do have to check our answers today. That's important. So let's look at number 1. All right, if I wanted to solve -5 plus the square root of 3x equals 1, this is the radical I'm talking about, the square root of 3x. I want to get that square root by itself. So what I'm going to do here is add 5 first. Move that to the other side. So I get the square root of 3x is equal to 6. Now I don't want to divide by 3. I don't want to go inside the radical. My next step says to raise each side to the power of the index. Well, undoing a square root, the inverse would be squaring. So I'm going to square each side. The square root and the exponent of 2 undo each other, and I'm just left with 3x. What's inside? 6 squared becomes 36. Step 3, I'm going to continue solving this. Now I can divide by 3, and I get x equals 12. But I have to be careful for extraneous solutions, so I always want to make sure I check. So I'm going to plug 12 in anywhere there's an x, and make sure that when I plug it into my original equation, it comes out to be a true statement. So I have -5 plus the square root of 3 times 12 is 36. I want to make sure that equals 1. Well, the square root of 36 is 6. And -5 plus 6, that does equal 1. So in this case, my check is good. So my solution is x equals 12. All right. In the second equation, 2 times the fifth root of 5x plus 2 minus 1 equals 3. Here's the radical I want to get by itself, that fifth root. So I need to get rid of the 2 out front and this minus 1. So just like if you were solving a regular equation, you always undo addition and subtraction first. So I'm going to add 1 to each side. So I have 2 times the fifth root of 5x plus 2, and that equals 4. All right. Now, 2 is connected to this radical by multiplication. So you don't want to subtract 2 here. What you want to do is divide 2. So I'm left with the fifth root of 5x plus 2, and that equals 2. 4 divided by 2 is 2. Now, to undo the fifth power, again, I don't want to go inside here and start moving the 2 or the 5x. I want to raise each side to the fifth power because the fifth root and the exponent of 5 are inverse operations. So I get 5x plus 2 is equal to 2 to the fifth is 32. And then I'm going to keep solving this equation. So I'm going to subtract 2 from each side, and I get 5x is equal to 30. Then I'm going to divide each side by 5 and get x equals 6. So I want to check my answer, plug it back into the original problem. 2 times the fifth root of 5 times 6 plus 2 minus 1 equals 3. So I'm going to simplify what's inside the radical first. 5 times 6 is 30, plus 2 is 32. All right, the fifth root of 32 is 2. So I have 2 times 2 minus 1. Hopefully that gives us 3. 2 times 2 is 4, minus 1 is 3. So in this case, my check works out, and my solution is x equals 6. Right? In my final example on this first page, I have negative 1 times the square root of 2x plus 8 equals 6. So here's that radical I want to get by itself, the square root of 2x plus 8. So I'm going to get rid of that negative 1/2 out front. Again, that's connected by multiplication, so you could divide by negative 1/2 here, or dividing by a fraction is the same as multiplying by its reciprocal. So if I multiply each side by negative 2, those cancel. The reciprocal of negative 1/2 is negative 2. And I get the square root of 2x plus 8 equals negative 12. Okay, don't do anything with the 2x plus 8 yet. Get rid of the square root. Well, the inverse of square rooting is squaring, so I'm going to raise each side to the power of 2. Then I will get 2x plus 8. Negative 12 squared is 144. And I'm going to continue solving. So I'm going to subtract 8. I'll get 2x is equal to 136. If I divide each side by 2, I get x being 68. So we want to check the solution. I'm going to plug 68 back into the original problem. All right. Underneath the radical, 2 times 68 is 136. 136 plus 8 is 144. Okay, so the square root of 144, that's going to become 12. So negative 1/2 times 12, we want to make sure that gives us 6. And here, negative 1/2 times 12, that's negative 6. That does not equal 6. All right, so when I plugged 68 back in, it did not work. So that means 68 is not a solution here. That's considered one of those extraneous solutions. So I didn't find any other values for x here. So since 68 didn't work, my answer here is no solution. All right, and I want you to think about right here when you got down to this point that said the square root of something, 2x plus 8, equaled negative 12. Right? What you're really saying over here was that you had a square root equaling a negative number. There's nothing inside of here that you could ever take its square root to give you out a negative number. So at this point right here, when you had an even root equaling a negative number, you might start to suspect that those are going to be problems where you have maybe no solution, or maybe you have a solution that's not going to be working, so it's going to be one of those extraneous solutions. So just be on the lookout for those kind of problems. All right, so we have 3 more examples. Okay. All right, so if I look at my next example, I have the cube root of x to the second plus 4 minus 2 equals 0. So again, just like before, I'm going to start by getting this radical by itself. So I'm going to add 2 to each side. So I have the cube root of x to the second plus 4. 0 plus 2 is 2. Well, I'm taking a cube root, so in order to undo a cube root, I am going to raise each side to the 3rd power. I undo these operations over here, and I got x to the second plus 4. 2 to the 3rd is 8. Right? And if you notice, we're left with an x to the second. So we're going to start to get problems that turn into quadratics. Right? So this is a quadratic, and I'm not going to give you any problems where you have to use quadratic formula. Those are going to be way too involved. But what I could have you do is solve equations that either ask you to factor or take the square root. And in this case, we can take square roots here to solve. I can just subtract 4 to the other side, and I get x squared equals 8 minus 4 is 4. To undo x to the second, I can take the square root of each side and get x equals, well, the square root of 4 is 2. But don't forget, when we solve and you take an even root of each side, don't forget you have to include those positive and negative solutions. So in this problem specifically, we ended up with a quadratic that we could solve by taking square roots. All right, so now I want to check 2 solutions. I want to check 2 and negative 2. So you want to do those separately. All right, so first I'll plug in 2. Make sure when you substitute you're using parentheses, especially when it comes to those negative numbers. I'm going to plug it into the original problem. 2 squared is 4. 4 plus 4 is 8. So let's see, is the cube root of 8 minus 2 equal to 0. Well, the cube root of 8 is 2. 2 minus 2 equals 0. Okay, so positive 2 checks out. So now I'm going to check negative 2. Again, I want to put this in parentheses. Okay, negative 2 squared is also 4, and 4 plus 4 is 8. So I am going to get what I got up there. The cube root of 8 minus 2 equals 0. And the cube root of 8 is 2. And 2 minus 2 is 0. So that works out. Okay. In my next example, x equals the square root of 6x plus 7. The square root of 6x plus 7, that's already isolated. There's nothing else over on that side with it. So what I'm going to do, the inverse of square rooting, is squaring. I'm going to raise each side to the second power. On the right, I just get out 6x plus 7. And on the left, x to the second power is x squared. So again, you notice we get a quadratic again. The only thing here is that I can't do what I did above. I can't subtract a term over and take the square root of each side because I have that x term. So in this case, when you get your quadratic, we are going to have to solve by factoring. All right, so remember, when you solve by factoring, you just want to move everything over to one side so that it equals 0. So I'm going to move 6x and 7 over to the other side. So I get x to the second minus 6x minus 7 equals 0. I want to factor this. So I want two numbers that multiply to negative 7 and add to negative 6. So that would be a negative 7 and a positive 1. And then from here, remember, you set each factor equal to 0. So my first solution, I get 7, and my second solution, I get negative 1. Now, we need to check both of these. You don't just want to circle them and say they both work. So let's start with 7. This time you have an x on both sides. So you're going to plug in x, 7 for x on either side there. So I'm going to say, does 7 equal the square root of 6 times 7 plus 7? All right, well, 6 times 7 is 42. 42 plus 7 is 49. And yeah, the square root of 49 is 7. All right, so 7 works. That's a solution. So now we want to check negative 1. All right, so let's see. Oops. Negative 1 equals the square root of 6 times negative 1 plus 7. So I want to say, does negative 1 equal 6 times negative 1 is negative 6 plus 7. Negative 6 plus 7 is 1. So does negative 1 equal the square root of 1? Well, the square root of 1 is 1. Negative 1 does not equal 1. And again, right here I got to a point where I was saying the square root of some number was going to come out as a negative. That can't happen. So negative 1 is not a solution. That's one of those extraneous solutions. So 7 here is our only answer. All right, our last example here. The square root of x minus 6 equaling x minus 8. So again, the square root of x minus 6 has been isolated. It's by itself. So to undo the square root, I am going to square each side. Now, what you have to be careful about, when you square the x and the minus 8, it does not become x squared and 64. You want to think of this as squaring the entire side of x minus 8. So on the left, I just get out x minus 6, but x minus 8 squared, we have to remember that's foiling. So you really get x minus 8. It's really x minus 8 times x minus 8. Do not say it's x squared plus 64. You need to FOIL that out. So if I FOIL out the right side, I'm going to get x to the second minus 8x plus 64. So I have x minus 6 is equal to x to the second minus 16x plus 64. And again, what I get is a quadratic. So I want to solve this quadratic by factoring. So I need to get everything equal to 0. So I'm going to subtract x, and I'm going to add 6 so that everything's on one side. So I have 0 equals x to the second minus 17x plus 70. I want to factor. So two numbers that multiply to 70 and add to negative 17. It's going to be x minus 10 and an x minus 7. Set each of those equal to 0. And what I think my two answers are 10 and 7. So your last step, you have to check. So I'm going to plug 10 and 7 back into the original problem. So if I check 10 first, I'm going to say that it's the square root of 10 minus 6 equal to 10 minus 8. 10 minus 6 is 4. 10 minus 8 is 2. The square root of 4 does equal 2. So 10 works. So now I'm going to check 7. Square root of 7 minus 6, does that equal 7 minus 8? Well, 7 minus 6 is 1, but 7 minus 8 is negative 1. So this is kind of like what happened in the problem above. The square root of 1 is not negative 1. The square root of 1 comes out as 1. You cannot have a you cannot have an even root come out to equaling a negative number. So 7 is one of those extraneous solutions. Okay, so the only answer here is 10. So you guys want to be really careful when I ask you to upload pictures of your work for your homework practice. Make sure you show me all of the steps in terms of solving, but also make sure I can see where you checked your solutions as well.